Hey everybody, this is Larry. This is me going with Q4 of the bi-weekly contest 137, number of ways to assign edge weights to. Hit the like button, the subscribe button, join me on Discord. Let me know what you think about this one. So first of all, for this one, it is hard but also doable. I think there's first thing I would say is make sure you get Q3, right? If you're able to get Q3, then this becomes a little bit or a lot easier because, well, I think it's a prerequisite, right? And then the second thing is that watch my Q3 video. Yeah, I mean, you can just search for it, right? I'll put it in the comments and the description, a link to it, but it's just number of ways to assign edge weights 1. Watch the end of that, or not the end of the video, but the end of the explanation, which is in the middle somewhere. So watch that as well for why a certain property is true. And that certain property being that if the depth is d, then 2 to the d minus 1 or 2 to the d minus 2 to the d minus 1 is going to be the answer. I explained it with some visualization. I don't want to repeat it again. And it's useful for that problem. It's useful. You need it for this problem, I believe. Maybe not, but definitely made it a lot easier for me. And then the second part is that I ended up taking 10 minutes on this, but honestly, like 7 of those minutes or maybe something like that was just me not Googling, but just I did this exact same problem a couple of days ago. And this is the exact same problem from one contest ago, literally the last contest that they had. So it's kind of a little bit crappy in that like I had to find the template for it, that's all. But as a result, and this is the problem that I did it for, minimum weight subgraph of the required paths. 2, I am going to put the link in the comments and the description, but so I will urge you to kind of watch that video. Well, look at the problem, look at that problem, and then watch that video. Because it literally was, I think I pushed that out like 3-4 days ago. I would basically say exactly the same thing about how LCA works and LCA template. I do go over how LCA works in a very short way, but yeah, if you want to go with that, you can do that. So here's the homework for this video for you, just to be clear. Watch Q3. I have a detailed visual explanation as to why 2 to the n minus 1 is part of the reason, or 2 to the d minus 1, right? And then the second one is watch the other video on LCA and stuff like that. Be really familiar with LCA and that video, because if you solve that problem from last week and you understand why LCA works, then this problem is like a 5-minute problem if you have everything set up, right? And I mean, in fact, I did it with 10, but I had to find the problem because I was like, can it be really the last week? It's just been last week, and yeah. So those are the prerequisites. I'm sorry that you have to do some more clicking, but it's literally like I did this explanation and I would probably just say exactly the same thing. Maybe in slightly better, maybe in slightly worse ways. I don't know. And today I am not about doing that. So I'll put the links below. But yeah. But then now, okay, so let's say you do understand why 2 to the n power works and understand why LCA works, then this is, like I said, a 5-minute problem. I have a lot of code, and a lot of this code is just copy and paste from last week. Like this is the LCA code. I'll go over it very briefly, but not like in any algorithmic detail. Like I said, watch that video. It's just not my time to do it again. But yeah, basically here we set up the adjacency list. We set up the LCA algorithm by doing the depth first search traversal, the in order traversal. We have a thing for calculating whether it's an ancestor. We do a binary search to calculate the LCA, or binary lifting, if you will. And then using that to get the distance. I have visualization on that contest from last week as to why this is the formula. And once you do that, then now, if u is equal to v, then the distance is 0. Otherwise, the distance is equal to this, and and yeah, the distance between the node is just the number of edges you have control over, right? And it's going to be that divided by 2, which is the proof that is 2 to the d minus 1, and the proof, like I said, is going to be on the Q3 video because I already did that. And honestly, and that's it. You just make sure that you go 2 to the d minus 1 and mod, and this is why people were able to solve it in 5 minutes. Well, at least the people who are not cheating. But yeah, that's basically it. I don't really have much to explain for this one. I just wanted to kind of give you the references to be able to go on. And I know it's a little bit of a crappy video, but I literally did all the work like very recently. So I don't know. Let me know in the comments. Maybe I could copy and paste those videos in, but then it's just like a weird cut edit thing. I rather just look at those prompts and maybe even understand and observe it a little bit more. But yeah, that is all I have for this one. Let me know what you think. This is my LCA code. This is the top. This is the recursive thing to pre-process both the binary lifting things and the timer things, all of one things, and login. I guess this one is just login for calculating LCA. Login operation to do distance. So now for each query, we are going to do a login query, and that's it. So it's going to be q login, and everything else is n login, right? So yeah, so the total complex is going to be O of q login plus n login time, and for space it's going to be plus n log n space, right? This part being pre-processing, this part being the live portion, and that's it. Let me know what you think. Thanks for watching, and yeah, I'll put the links below. Let me know in the comments if you have any specific questions, and I will talk to you later. You could watch me solve it live during the contest, but honestly, it's just me not remembering what the name of this problem is or whatever, because I don't remember stuff anymore. So I just was like, okay, let me find this, and it took me a while, and then kind of just like make minor changes so that it works. And yeah, and you could watch me do that now. Only after I did like crazy amount of things. All right, let's do Q4 now that we observed it. Apparently a lot of people probably did it just not dumb way. Okay. Still rooted 0, 1, 2. You're giving more ways to assign it to the edges in the path section between you and we. Okay. Is it not the same way, you know? I'm opening it back up because I could reuse it. Actually, why does that work? Because this one edge. Actually, I don't know why this works. I think it's just intuition for me. But as a result, we can probably do the same way, right? There's just like, there are a couple of ways you can write it. Maybe LCA. Did I do that recently? I think I did that recently. So I have code maybe. LCA. Alright, I'm not gonna lie, I'm gonna cheat a little bit. Yeah, because I did this like literally within the last week, so that's why. So you know, I'll show you how I'm looking it up, so it's not like, you know. So it really was like recent, right? Like and I was, because I did a video on this. No, not that one. Is it this one? Nope. Oh, path existence. Maybe that probably makes sense. Right. Yeah, and I kind of wrote all this stuff. This is still not that one though, actually. Unless it was that one and I just kind of... It literally did it recently. No, I mean, this is the thing, so why doesn't it look like... I did the one with the... Wasn't it LCA? Well, I don't even have my... I mean, I wouldn't call it a template, I'm just lazy, but... What is this form again? I don't even know what this poem does, but it is... maybe it's a little bit more... Oh, shortest path in the weighted tree songs. Right, okay, yeah. No. No, I definitely had a... looking at poems. Not in the medium, but like I did the LCA algorithm. I could do it again, but just that I'm lazy. You know, so like literally was like within the last week, so it's not like is it literally maybe this one? Was it last week? Last week literally? No, it was actually last week, so it wasn't even one of the ones I was doing catch up. Alright, that's kind of actually pretty crappy. But okay, fine. So we don't need all that, we need okay, so this is the LCA-ish part to get the distance. And I think it's funny because I think doing that problem I was like, oh, you have this template, you could probably do it in like 5 minutes. But and this one is probably about the same. I'm looking the right problem. Okay, yeah. Do I need D? I guess so, but the D is 1, so it's fine. So then now we just do this on the node 0. We want to copy this stuff from Q3, in case you're wondering where that's from. Okay, so then now we should be mostly good. I don't need this anymore. I need to... I need parents for ancestor? I don't think I need... I guess I do need it for parents. It's been a while. I don't... it's kind of weird though that they literally ask you to do this. Is that all I need? Okay, so then now we have distance between 2 nodes, right? Yeah. And then now, I don't need this anymore. Hopefully, I can open it again, so it's not a big deal. Query UV, right? So for UV and queries, we're going to get the distance between u and v, right? So d is equal to and then if it is right, then it's just mod power of this minus 2 and then mod, right? Which is what we had before. I guess the upsolving didn't UV and edges, where is that? Line 30. So I guess the upsolving didn't hurt in the sense that I kind of needed this formula. That was kind of weird because I actually don't. It just kind of came to me. I don't know how I know that formula or how to prove it. Line 40. I have to fix this though. Time in, time out. Why is it out of bounds? Because of n. N is the number of edges plus 1. Is that not right? We don't have m though. M is... let's just say 18 anyway. I always... But out of bounds on a p. Okay, so we try to call distance. Oh, because this is is that the answer? Why is it so long? Okay, so maybe I mean, we still need LCA anyway, but why is that? So the distance of 1. So then if it is 0, maybe it's just wrong for... It's not... Maybe distance is from the root is different. 214, okay. So now we're right. Of course, 0 is going to be wrong because we do d minus 1, right? So if u is equal to v, enter that pen 0. But I don't even need to calculate it, I think. Else we do this thing. Okay, now the answer is right. So let's give it YOLO submit. If it's wrong, that's fine. We spent like 5 minutes, right? And it's right. So, but we'll have the template, right? So we, if you want to watch me write out this template, is from that video. Oops, wrong button again. But okay, fine. And honestly, like 10 minutes, but like most of those 10 minutes were copy and pasting and try to figure it out. It's kind of a silly problem, honestly. But yeah, I mean, I don't know. To be honest, though, I also don't know how I came up with that one. Did I just notice it? I guess I just noticed it, but it's one of those things where it's definitely one of those things where like it just triggered and then you test it and it worked for Q for whatchamacallit. Yeah, I don't know. Honestly, I think I'm just trying to justify Q3. I think Q3 I just noticed it, but why is that right? I'm not sure. But why do I think it's this? Honestly, I'm not sure. Maybe I cheat. I'm making optimize. Whatever, we'll do that. Why is this right? What was Q2 again that I spent so much time on? I think now, honestly, I'm just trying to justify Q3. I saw this and I kind of test this and play around with it without knowing that I need it for Q4, honestly. But I don't know that I could do it without it. Maybe you can. I don't know. I don't know what the way to do it is, but this one obviously made it easier. And now, honestly, I know I already did the contest, but I'm still trying to figure out why this works exactly. I see. No. Well, okay. I have an idea, but maybe it is just a lot of it. Maybe it's just luck also, but it's this idea that okay, So let's say you have max depth, right? So let's say you have some m is equal to max depth, and to be odd, and we could go through the two cases, but I think it's easy anyway. But yeah, but like we have m, then the idea is that okay, let's just say for now m is even, right? Then now you have one of this, and then they're all evens, right? Or this, I guess it doesn't matter if it's even or not, but something like this, right? And I think as a result, and if you can't do the math, it's going to be like and then you choose the math, right? But that's just crazy that it actually I mean, it is one of those random Pascal triangle properties that maybe just kind of grained into my head, but that is just honestly more lucky than anything. Yeah, because I mean, I definitely, as you saw, I definitely was gonna. I mean, I did it the other way anyway, but for some reason, I just felt like I really wanted to test this. But yeah, the idea is that okay, so this is gonna be m, choose one, right? And this one is gonna be, is it m choose one? No, it's like so there's m plus one dividers. No. No, this is m choose one, right? And then this is like m choose three, I think, right? In some way. Like the way that I visualize this is a little bit funky, right? Because the way that I think about these are all Pascal triangle, and as a result, what I want is that you can think about. I'm bringing up drawing board, even though I know the contest is over, so this is a very weird part. I mean, I'll probably go over more in detail in the explanation, and this is just for myself. But basically, you could think about it as like triangle, with a Pascal's triangle more specifically. I'm too lazy to bring up drawing board, but something like this, right? And then the idea here is that going left is 1, going right is 2, maybe, right? And then the idea here is that yeah, you sum up all the counts of every other one, right? Or I mean, it depends on the depth, but it turns out it didn't matter, right? Because for example, here then this is all 1, so you want this one, you don't want this one, because then this would. Did I drew this weird? Maybe I drew this weird. Well, I drew this weird in that they're not next to each other. Sorry. So maybe that's why. Yeah, okay, I drew this wrong. So it should not look like that. That's why it's a little bit weird. I kind of rushed this drawing, but because the reason is because yeah, that's just weird. Okay, I see. All right, let me just redraw this one. All right, no. Okay, so do right. So you have this after 1 hit, and then this is after 2 hit, and then this is after 3 hit, right? So this is more accurate, I think. So that's why, right? So then I get 1 2 1 2 1 2 1 2 1 2 1 2, and honestly, this is how I visualize things. I think sometimes, I don't know, maybe people think like I'm nuts, but you want this one because now this is odd, right? But here, like if I go to this one, that's even, right? And in any direction, it's going to be even because you go through even number of ones, right? So then now it's going to be the circles that you want are going to be here and here, right? And as a result, but the thing is that, and this is a Pascal's triangle thing, right? So you have, I don't know, in this case it'll be 1 1 3 3, right? In the number of ways. And then, but the thing is that this row is going to be 2 to the n, right? the sum of this row is either 2 to the n or n minus 1 or whatever, right? Like I know it's a power of 2, and this is Pascal's triangle property, right? But then now, if you notice that you took away half of them, then it's just going to be divided by 2, right? Hence 2 times n to the 1. And that's why, okay. I guess I kind of ate a lot of this intuition, which is kind of nuts if you ask me some days. But that's how I would think about this one. Let me know what you think. Yeah, actually, thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, this contest, everything in between. Yeah, stay good, stay healthy to commend to health. I'll see y'all later. Take care. Bye bye.